Given A, the 3 by 3 matrix with entries 1, 1, 1, 0, 0, 1, 0, 0, and 1, find A squared, A cubed, A to the 4th, and A to the nth power. We'll start with A squared, which we can get by multiplying A by itself. When we multiply a 3 by 3 matrix by a 3 by 3 matrix, the result is also going to be a 3 by 3 matrix. And in this case, we're going to have 4 entries that are 0. You can verify this by looking at the inner products that give us those entries. What we're going to focus on here, though, is figuring out the other 5 entries. Let's start with this first entry here. This will come from the inner product of the first row and the first column. The only product here that's not 0 is the first one, 1 times 1, which is 1. The others are 0, and so we're just left with 1 here. In fact, the same thing is going to happen for the next entry. We take the inner product of the first row with the second column, and again, the only product that's going to be non-zero is the one right here. 1 times 1 gives us 1, so we'll have a 1 here. In fact, the same thing will happen with the 2 entries on the right, in the middle and below. The only entry where we're going to get something else is going to be the one in the upper right corner. So let's actually take a look at the inner product that gives us this. It's going to be the first row and the third column. And when we take this inner product, we get 1 times 1 plus 1 times 1 plus 1 times 1. And in this case, we end up with 1 plus 1 plus 1, which is 3. So A squared as a matrix looks just like A did, except the entry in the upper right-hand corner is 3. Let's take a look now at A cubed. A cubed is A times A times A, or A squared times A. So we can take the result that we got for A squared, and we can put it here, and we can multiply it by A. Again, we have a 3 by 3 matrix times a 3 by 3 matrix, which will give us a 3 by 3 matrix. And just as in this example we looked at before, there's going to be 4 entries that are zeros. And the other entries, aside from the upper right, are going to end up being 1s. You can check either of these by doing the inner products. I am skipping some of them to make this video a little bit shorter and not go through repetitive calculations over and over. The entry that we're most interested in, though, is the one in the upper right-hand corner, which we get by taking the inner product of the first row and the third column. When we do that, we've got 1 times 1 plus 1 times 1 plus 3 times 1, which is 1 plus 1 plus 3, which is 5. So just like with A squared, we've got a 3 by 3 matrix with 4 zeros, 4 1s, and then the last number now is a 5. If we want to move on to look at A to the 4th, we know this is A times A times A times A, and so we can write A squared times A squared. And we're going to see so many things similar to what we've been seeing before. So much of math is looking for patterns, and in this case, we can see that again, we're going to have a 3 by 3 matrix with 4 zeros and 4 1s. The most interesting thing, though, is what's happening on the upper right-hand entry. To figure that out, we again look at the inner product of the first row and the third column. And when we do that, we've got 1 times 3, which is 3, 1 times 1, which is 1, and 3 times 1, which is 3, and 3 plus 1 plus 3 is 7. So we've got a squared, a cubed, and a to the fourth. Hopefully, at this point, you can see what the pattern is for a to the nth. Each power of a is going to be a 3 by 3 matrix with 4 zeros in the lower left-hand corner, 4 ones above and to the right of those zeros, and then if we look at this last entry, we can see that it's been 1, 3, 5, and 7. These are all odd numbers, and specifically, we can get them by taking the power, doubling it, and subtracting 1. So 2 times 4 is 8, minus 1 is 7. 2 times 3 is 6, minus 1 is 5. 2 times 2 is 4, minus 1 is 3. And so for a to the nth, 2 times n is 2n. And when we subtract 1, we get 2n minus 1. So a to the nth power here is the 3 by 3 matrix with entries 1, 1, 2n minus 1, 0, 0, 1, 0, 0, and 1.